Today we are talking about pattern sequences and series. Going to refresh your memory on this concept, okay? A lot of what we're going to do today is going to be example based because really and truly you have the formulas in your reference book under topic 1 for algebra, okay? You have two different types of sequences. What are they?
Arithmetic and geometric.
What makes something an arithmetic sequence?
A lot of addition.
If you're adding a what?
A constant.
And what was the name of that constant? It had a special name.
N.
Not N.
Oh.
The starting point?
No.
Oh, what was it called?
Look at the formula for arithmetic sequences. It was D.
Oh, good job.
D stood for
what is
not
it called?
distance.
What is it called?
Similar. Come on now.
The value you're looking for.
It's the it is a
Common
constant.
difference.
It's called the common
I
difference.
see that.
D for difference. D for difference. So it's common difference. You were adding a particular number, common difference, to the previous term. Geometric means you were what?
Multiplying or dividing.
Multiplying solely. So if it was a fraction, then you were or if you were dividing by 2, you were really multiplying by a fraction, and this would be called your what? Your ratio, your common ratio. Okay? And so within geometric, you have finite sequences and then you have infinite sequences. But all your formulas are there inside of your reference book. So a lot of what we're doing today, pretty much all of what we're doing today is doing example problems and then hitting the important points as we do these example problems. So let's take a look at this one. It says find the 27th term of the arithmetic sequence for which u sub 1 equals 29 and d equals 4. Starting you off very simply, okay? Here, which formula are you going to use?
The nth term of an arithmetic sequence.
Okay, what is that formula?
Un equals u1 plus n minus 1 times d, parentheses.
Let's review what everything means. U sub n represents
That specific term.
that's a specific term, so the nth term. U1 represented the
First term.
first term. N represented the
That number, that nth term you're looking for, or rather that specific nth term.
okay. So the number of terms. So if you're looking for the 27th term, then you would plug in 27, and of course we just reviewed what D stood for. D was your common difference, okay? And so, like I said, this is a very simple, very basic type of problem. Go ahead and tell me what is my 27th term.
133. I saw the error I made in my math.
Okay, so we're going to plug in 27 for n. U sub 1 is 29. So then it's 27 minus 1 times 4. So what did you guys get? 133. Very good. Okay? Again, this is the most basic, most simplest problem that they could ask you, or even, what's the common difference if they give you a sequence. Those are some of your most basic ones. But remember, this formula can be used to find any one of these 4 pieces of information, such as this next one. Go ahead and find n in this problem. What is the value of n?
10.
It is 10. So you use the same formula. Take a look. That's why. Okay, you plug in 96 for u sub n, 42 for u1. You are looking for n, and d is 6. Okay. Some of you guys maybe distributed, combined like terms. Me, I probably would have subtracted 42. This would have given me 54 equals n minus 1 times 6. I would have divided it by 6. This is just me though. And n would have equaled 10. Now, what does n represent again?
Your number of terms.
So n always has to be 2 things. What two things? N always has to be
Positive.
positive and a whole number. So if you work this out and you realize that you get n to be something that's negative or a fraction, that probably means somewhere in your math you did something wrong, or maybe even on the original setup.
You forgot to convert to radians.
Not so much for these. Thank goodness. All right. Let's do this one. Let's see who remembers in these types of problems. Okay, so I saw this. Like I said, I saw this being worked 3 different ways. One way that you could have worked this problem is you could have used the fact that, okay, since negative 16 is my 5th term, I could have plugged negative 16 16 in for u sub n, I could have had u1 plus 5 minus 1 times d, and then I could also set up negative 4 is equal to u1 plus 8 minus 1 times d, and you would have a system that you could solve for d and u1. Because you need both of those in order to find the 20th term. That's one way you could do it. Another way is you could have temporarily made the 5th term the 1st term, which would have caused you to push back the 8th term to make it the 4th term, and then you could have plugged in negative 4 equals negative 16 plus 4 minus 1 times d to find your common difference this way, and then of course readjust.
That's what you're.
Okay? That's what you did. Another way that you could have had it done, you guys remember that shortcut I showed you?
Nope.
Wasn't it like, well, I just let you.
Yeah, there you go.
You subtract the terms,
Yes.
and then you divide it by where they're placed to find your common difference.
Oh, sick.
Okay, 2 negatives make a positive, so that becomes positive 12 over 3. So your common difference is 4. This trick right here helps you figure out the common difference. And then you can use that to find your first term.
Is that what you do, Francisco? How did you remember that?
By plugging in, and your first term should have been negative 32. It's the same thing you would get if you did it any one of these other 2 ways. But no matter what, you needed your first term and your common difference to find the 20th term, which it was asking you to find. So you got to make sure that you actually finish off the problem. Common difference was 4. So then that's negative 32 plus 19 times 4, which is 76. So then that would be 44.
You see, it's funny you should say that. Because I did the third one and the second one combined. Like, I did the third one, found D, and I completely blanked on how to find U sub 1, so I used U sub 8 as U sub 1, and then I was like, okay, well...
How many more does it take to get to 20? Yeah, you can definitely do that.
I did
As long as you consistently move the terms down through the sequence and the lines, you're good to go. What'd you say, Samuel?
Oh, I just said I did something different after we got D equals 4. And that I did 5 minus 1, you know, the 5th term minus the 1st term. I got 4, and then I multiplied 4 by 4, and then I got 16. Wait, where did I go from there?
And then it sounds like you probably subtracted 16 from negative 16.
Yes.
So yeah, it was kind of a variation of that second one to find that first one.
This is a math teacher.
She is math teacher.
I meant to say line
She is a math teacher.
Okay, find the formula.
Now when it asks you to find the explicit formula, it's basically asking you to find something that I can use to find any term in the sequence, okay? So we'll do this one together just in case. I'm still going to use that same formula that I've been using because I'm still dealing with the sequence. But this time, what am I not plugging in for?
The N.
I'm not plugging in for n,
You're just finding a general equation.
which will be u sub n. So what's u sub 1?
7.
I'm not plugging anything in for n, and what's d? 3. The one thing you don't want to do is leave it like this. You want to distribute and simplify. So u sub n equals 3n plus 4. That is your explicit formula, yes?
Why do we have to expand? Why can't we leave it like that if that's the format for it?
Because it's not simplified. It's not the most simplified form. It's the same reason why you don't leave 2/4 as 2/4. You simplify it down to be 1/2.
Oh, that
It's
makes
the
me
law.
cringe. 2/4, could you imagine?
I would. Okay?
2, 4, 6.
Do you get our tests back? Like paper 1 and paper 2.
I can, but
But
so
all-
some.
375.
375.
Yes.
That's perfect.
Uh-oh.
Did you say 1/6?
I second Sam.
Okay. Well, let's go over it. We're looking at the sum of the first 15 terms, so it's 15 over 2. The sum of the arithmetic sequence starts the same way, but remember, there's 2 formulas, right?
Yeah.
One of them
Is for when you don't know the 15th term, and the other is when you do.
And we don't know the 15.
correct. So this one, if we knew what the 15th term was, we could use it. But then the other one, which is the one we probably want to use here, is 2u1 plus n minus 1 times d, correct?
Yep.
So that's what we do here.
very strong.
What's the common difference?
4.
Good stuff. So then this becomes 14 times 4, which is
56.
56.
Minus 6 is 50.
7.5.
Wait, no. Hold up.
I didn't do 7.5. I divided 50 by 2 and then multiplied 25 by 15.
I multiplied 50 times 15 and then.
Okay. So we do know that this is 50. And to be honest, however you do it is kind of really up to you. Me, because this is not calculated, I probably would have reduced this and turned this into 25 and then multiplied 25 by 15.
I did that.
And then you get 375?
Yep.
Should be
I just-
375.
I did.
I didn't get 375.
I did
I got
50
275.
times 7
y'all
and then
did
just
don't
Wait.
divide by
Wait.
2, add
Miss
it.
Anderson, I need you to add an extra 0 after the 5.
I always get the sausage.
Why?
Just do it, please.
Oh. I did.
Boom. That's how the government does our taxes.
Oh, look at this, look at that.
What's gonna happen?
Alright, geometric sequences, starting you off in your most basic. Starting you off in your most basic. Calculators out. All the other geometric ones we'll do with the calculator.
Miss Anderson, have you ever seen the Indian guys build?
Like I'm on the outside of
Which-
some intricate inside joke.
What formula do we use here? What formula are we going to use here?
U sub 1 times r to the n minus 1.
Very good. This is geometric. What's my first term?
36.
My ratio?
1/3 over 3.
And n.
5.
Very good. Give it to me as a fraction.
Oh, wait, no. The
Wait,
N
no,
is
N is
No,
six.
it's 6 minus 1.
Oh.
6 minus 1, so it's
It's
5.
Yeah.
We just did it ahead of
That was
time.
a big eraser. So 6 minus 1, which is 5. So then give it to me as a fraction.
4 over 27.
4 over 27. Good stuff. Now, real quick, because this is geometric, how would I show or find the common ratio?
You take 36 and divide it by 12. Or
No,
put it
no,
over-
no.
Other way around. Flip that.
Yeah, never mind. The other way. Yeah.
Yep, the other way around. 12 over 36 or 4 over 12. Okay, that's your second term divided by your first, or your third term divided by your second. No matter what, it should equal the same value, which is 1/3. Don't forget about that there. Here, find your second term, given this information. What do we get for our answer?
6.3.
Just type it in.
Wow,
Okay,
so
since you were given your fourth term, you will plug that in for u sub n. You don't know what your first term is, but you do know your common ratio is 3. So basically, you would divide both sides by 9, because that turns into 3 to the, not 9,
27.
27, because that comes 3 to the third. So my first term is what?
2.1.
And since you're looking for your second term, you basically take your first term and multiply it by your common ratio.
Wow. Math.
Yeah?
Big maths.
Let's keep going.
Quick math.
That's
This one hopefully didn't trip you up. What type of sequence is this?
Arithmetic.
So you actually had to use the arithmetic formula to find the value of n. Okay, what's the common difference?
4.
And what was the value of n? See ya.
19.
Very good, okay? Yep, do an arithmetic one in there. Just make sure you're paying attention. Okay, identify what type of sequences they are before you start applying your formulas. What about this one here? Find the sum of the first 6 terms of the series. All right, so first off, geometric or arithmetic?
Geometric.
Which means there's a common ratio of,
3 over 5.
remember you find that by doing the second term, dividing it by the first term, and this is the, I mean, you were using your calculator, but you know, keep, change, flip as well, and reduce. Since it's asking for the sum of the first 6 terms, is that finite or infinite?
Finite. I mean, infinite. Finite.
This one is finite because it's asking for 6 terms. Even though it does have the ellipses at the end representing that sequence goes on forever, you're only finding the sum of the first 6 terms. So you're going to use the formula that says u sub 1 times r to the n minus 1 or 1 minus r to the n.
R to the n minus 1.
Okay?
Oh, wait a minute. These are pretty much the same thing.
N is 6 minus 1. They are the same thing. It's just you want to make sure that whichever way you do it, you keep it consistent on the numerator and the denominator, okay? So remember, alpha y equals, option 1 pops up that fraction for you. I'm going to have a fraction within a fraction, so I'm going to do it again. So that's going to be 3/4 times 3/5, right? To the what power? 6?
dumb butt would
Minus
just do
1?
everything in parentheses and dividing and waiting.
I mean, and if I didn't have this type of calculator at home, which I don't, I have a very old school one. I probably would have done each piece, simplify the fraction, and then gone from there. Convert it to a fraction. Remember math. Enter. Did you guys get that?
Yes.
Yay.
5586 over.
3125.
If I did leave it as a decimal, which was
8.
1.79.
1.79, 3 significant figures. Do you know if it keeps going after that too?
Yes.
Yes.
Well, I think so.
You know,
Just 3 significant figures if that's the case.
Oh, Miss Anderson, can I join you and Nicole's club of having a headache? Because my withdrawal's kicking. Yeah.
What?
Arithmetic or geometric?
Geometric.
What's the common ratio?
2 over 3.
And it asks you to find the sum. Is this finite or infinite?
Infinite.
Yep, it has the ellipses and it doesn't tell you to add up how many, and there is no end here. So the formula is your first term all over 1 minus your ratio, correct?
Yes.
See?
So when you simplify it and keep change flip, what do you get?
6.
Simple enough, right?
Yeah.
What?
So this is pretty much what you were dealing with. Of course, the word problems come into play and trying to be able to recognize arithmetic and geometric, and so in your homework you'll have some of those. Yep.
Is there a preference for leaving in decimal or fraction?
Well, remember, leaving as a fraction, you won't have to worry about losing that rounding penalty if you don't round to 3 significant figures.
Yeah.
So remember, you either leave it exact, the 6/5, or correct to 3 significant figures.
Okay, basically that won't be too hard to remember. That's pretty much one of our big shticks.
That's right. One of the other concepts that came with the sequences, specifically the geometric sequences, is when you had a series that was either convergent or divergent. Do you guys remember the differences between those words?
Oh, convergent is like it's infinitely growing. Divergent means it's getting closer to 1.
or
0.
Dang it, yeah, you're right.
I think you guys have the right idea.
I think it's the other way around, right? Because you're like converging
to
with
0.
to 0 and then divergent.
Well, let's take a look at these two examples I have here for you. The first one I have 2, 6, 18, 54. First off, is geometric, right?
Yeah.
What's the common ratio? 3. And so could you ever actually really find the sum of this?
No, not really.
No. So because of this, that means it's not going to go towards a particular number like it would for an infinite sequence, you know? So would this be convergent or divergent?
Divergent.
Yes?
Divergent.
I'm gonna go with divergent.
The sum would go to infinity because it's just going to keep getting bigger and bigger and bigger. So is that convergent or is that divergent?
Divergent.
Divergent.
Is divergent?
Yeah.
Unless we have the definitions backwards.
Huh?
Unless we have the definitions backwards. But
I think originally when it was said, I think we did have it backwards. It's be divergent, okay?
Yay.
Because you're right, when you converge, you're going towards a particular value. What's the common ratio for the next one?
1/4.
Yeah. 1/4.
1/4? Okay, it's 1/4. And remember, when the common ratio is in between, well, the absolute value of the common ratio is in between 0 and 1, that meant it was a convergent series. So this one is convergent. Okay? Remember? Yes? Yes. Good stuff. Okay. The other part of pattern sequences and series was Pascal's triangle and combinations and expanding binomial. It still should be in the same, it's still in the same topic, still on the same page of the reference booklet. Whenever you see this notation of 6C4,
Scream.
6, no, it's easy. 6 represent what?
The 6 tier.
The number of terms.
Not the number of terms, the 6th tier. What do you mean tier?
It's like the 6th level.
The 6th level, the row of your Pascal's triangle. So this was the row, and then this was your,
Over 4.
in that row.
that basically you had to go over 4 terms. But remember, it always starts with 1, and 1 was always your 0 term. Pascal's triangle, remember, it had an array of 1s, and then how did you get the numbers in the middle?
You add them up.
You add them. This will be 1,
3, 3, 1.
The next one, 1.
4, 6, 4, 1.
Next.
1, 5, 10, 10, 5,
Oh,
1.
right.
And 6.
1, 6, 15, 20, 15, 1.
Okay, so remember, this N basically told you what row it was, and 4 basically was the 4th term over. But remember, this was always your initial, then 1, 2, 3, 4. So 6 C4 or 6 combination 4 would be 15. Okay? Now, what if N was like 13 or 20? You're not expected to write out that entire big old triangle up until that particular term. That's when you have the formula in choose R in your reference booklet.
Yes.
Does everybody see that formula?
Yes.
What did factorial mean?
Basically you
6
multiply
times 5
every,
times 3 plus 2 times 1.
yeah,
Mhm.
you multiply every number that comes before that number term.
Very good. So this would be 6, choose 4. So that'd be 6, 5, 4, 3, 2, 1.
4, 3, 2, 1.
4, 3, 2, 1.
You can just cancel out those like terms.
Mm-hmm. And so your 4, 3, 2, 1 would cancel out. And remember, I also showed you 2 can go into 6.
3 times.
And what's 3 times 5?
15.
You have 1 in the denominator.
Oh, that, yeah, it's
Y'all remember that?
Remember
Why do I remember it is so much worse than that?
Because it came when it came with the expanding binomials, which we'll get to in just a second. But just to make sure that you guys have this, can you guys do this without your calculator, please?
Yes.
Only because
No, this is a very not just is it? No calculator?
I don't know what you do with no calculator.
Oh no, I'm wrong. I'm very wrong.
Okay.
Easiest way to do it is to take, when you start reducing, you should take it out of the biggest number possible. 7 goes into 14 twice. 6 goes into 18 3 times. 5 goes into 15 3 times. 4 goes into 16 4 times. 3 goes into 12 4 times. 2, to be honest, I'm going to get rid of this 2 that I already have there.
oh,
So then I'm left with 3 times 17 times 4 times 3 times 13 times 4. Okay?
I feel bad because I forgot to include 7 factorial and because I'm in the hundreds of thousands right now.
Okay?
Oh, geez.
4 times 3 is 12. 12 times 12 is 144. I'm going to multiply that by 17. Now, of course, realistically, the likelihood of this being without your calculator is probably very slim. But I just wanted to make sure that you guys are using the formula.
Too strong. Loud and long.
3, 1, 2, 2, 4.
We were best friends.
I got
3, 1, 8,
31, 8,
2, 4. We can always check using our calculator. You guys remember how to do it in your calculator?
Yes.
You got this
Math.
freaking
Math.
kid.
Math.
Hit left twice for prob.
Go over to prob. Option
And
Three.
CR.
3. Now, if your calculator is like mine, I can just fill in the holes, okay? N is 18, and R was 7, okay? If yours is like Griffin's, potentially, you have to do 18, then go to MathPRB NCR, and we get our answer.
Freaking 10, you did it.
Where's my practice today? If I never had
Sigma notation was also a part of this. Sigma notation was also a part of this. It did deal with patterns and things like that, but more so with some arithmetic and geometric. Sorry, these are out of order. I thought I fixed this when I first did the slide, but I guess I didn't.
I don't think any of us really hates most of this. It's just like the process of remembering them in addition to all the other
Other
junk
things.
we're going to have to remember.
But it's like, for this, out of all the sections, this one has the most formulas that are given to you. So remember, this is the format, this was the setup, okay? Remember, this bottom part always represented your starting number, your starting term. Okay, so we're going to start with our first term, and then the top number always represented where we ended, so our ending term. Okay, and then this inside part represented our formula, the explicit formula if it was arithmetic or geometric. And if you look at this, is this arithmetic or geometric?
Geometric.
How can you tell?
Because multiplied by 5.
Just because the 5 is being multiplied to the end, you're subtracting 1. If I were to plug in 1, my first term, what would I get?
Just 4.
I'll get 4. What if I plugged in 2 for my second term? 9. What if I plugged in 3? Are you sure it's still geometric?
No.
No, it's actually
Arithmetic.
and this 5 represents
Your D.
our common difference. That's how it is when it's the explicit form simplified. The number that's attached to your variable is always your n.
Guys,
It's always your d. It's always your d. So, I mean, I can keep on going at this point because it was only asking me to go up to 5 terms, plug in 4.
It's just going to be 19.
And then the last term, our 5th term. So then I would just add all these terms together with 9 plus 4.
13.
Okay, was 13 plus 14?
27.
Was 27 plus 19?
46.
And was 46 plus 24?
70.
Good job there.
That'll
No,
be
it's a
the
good
sum.
job to us all because it's a community effort. Because that's how communism.
Now, if that explicit formula is arithmetic, of course you can use the formulas as well. You just have to identify if it's arithmetic or geometric. Questions on summation notation?
So bad.
Okay? So you can either identify if it's arithmetic or geometric, or you can plug in your terms and add them up together. Either way works. Do this one.
What?
What's the sum?
11.
How did you do that so fast?
Because all you're
6
doing
plus
is
3
you're plugging your
there's only
terms.
3 terms. So
Yep.
I guess I just added it.
What were you doing the whole formula?
I was doing the formula.
But again, my question is though, so you have, but by the 3rd term, you got your terms, right?
Yeah.
6, 3, 2, and are they? Is this geometric?
No.
Arithmetic?
No.
So you are gonna have to do it this way, just plugging in your terms.
Yeah.
So it's just like.
It's not a pattern. It's just a B like that.
All right. Finishing it off with binomial expansion. We're not going to expand this one. We're going to expand the next one after we review some of the topics or some of the things that you need to remember when you expand a binomial. Who remembers some of the things when it comes to expanding binomials?
You got 3 sets of parentheses.
You do have 3 sets of parentheses. What went in the first parenthesis?
X minus y.
No,
Mm.
it's your exponential, which is in this case will be 3
3.
over.
3 over something. So it would have been your n over 0, because wasn't this always n?
Yeah.
N over 0, n over 1, n over 2, so on and so forth. What went in your second parentheses? Your first term, your last parentheses,
Second term.
your second term. And these were what?
Exponents?
They had exponents.
That added up to n.
Okay, so that was one of the things. Your exponents had to add up to equal n no matter what for every single term in that expansion, because this is just one term. Okay? What else? What else was special when you expanded binomials?
Oh, the largest exponent of a variable was 1 less than that. So 2. Wait, is it 1 more or 1 less?
What are you talking about?
Like, isn't it something like the exponent is 1 less?
I think you're on to something.
It always has
The number of terms.
It was your number of terms was always what?
one more.
Yep. Your number of terms was always 1 more. Then your exponent. So in this particular case, this expansion would have how many terms?
4.
It would have 4. An easy A1. Write down the number of terms in the expansion. What else? What else?
You
Oh, coefficients.
What about the coefficients?
Oh.
What were the coefficients
Oh.
of the expansion?
Oh, the Pascal's triangle thingy.
Oh, you need to incorporate Pascal's triangle.
Yep, and that's where the coefficients came from. They came from Pascal's triangle.
Then you multiply.
There was one more property, one more feature. You can't think of it. Let's expand this and let's see if you can remember. How many terms should this expansion have?
5.
So that means I'm going to have 5 sets of 3 parentheses.
Oh boy.
Okay? In that first parenthesis, it always went in. But then it'll be in, choose,
0.
in, choose,
1.
in, choose,
2.
in, choose.
Wait, shouldn't it be 5?
It's always the value of n to the 4th power.
Then where do we get n plus 1?
N plus 1 represents the number of terms you'll have. Remember, the number of terms is always n plus 1. So since we have an exponent of 4, that means we should have 5 terms as binomial expansion.
Okay.
And it should always go up to 4 or n choose n. What goes in my first parenthesis?
2r. Yeah.
What about my last parenthesis?
Negative 4s.
And it should be negative. Make sure you always carry the sign with the second term. What about your exponents? I know they should add up to equal n.
Oh, let's do 4 and 0. 2r to the 4th, and 4s to the 0, and then
4 and 1.
2r gets decreasing exponents, while negative
3.
4s gets increasing
3.
exponents.
2.
That was the one that you guys couldn't remember. What's this one?
1,
3.
And this one?
0, 4.
That was that last stipulation. Okay? Your first term's exponents decreased while your second term's exponents increase. All the way up till you get to n or all the way till you get to 0.
Yeah, this is definitely the hardest part.
Okay? And so then from there, it would be nothing but actually doing the algebra and multiplying. These numbers came from Pascal's triangle. Okay?
Do we solve for each and then add them all up?
Every single one, you'll end up adding them.
Okay, because I thought we only did like one or the other.
What's 4 choose 0?
Isn't that 1?
That's 1. Just like 4 choose 4 is 1. What's 4 choose 1? So this is 4, this is 4. What's the one in the middle?
8.
Wait, how do we get these values?
6.
Remember, they come from Pascal's triangle,
6.
or we can do this here.
6.
It would be 6. Okay, there's the 4th row.
Yeah.
So again, we either do want to use this formula, or we can use our knowledge of Pascal's triangle. So here I'm going to multiply 1 by 2r to the 4th power. What's 2r to the 4th power?
8 to the, 16 r to the 4th.
Very good, because what's negative 4s to the 0 power?
1.
1.
So that's just that.
Then I'm going to multiply 4 by 2r to the 3rd. What's 2r to the 3rd?
8r third. So it's
And
24.
so it'd be 24r to the 3rd. Then I have to multiply by negative 4s. What's 24? Or not 24. What's 32 times negative 4?
Negative 128.
So it'd be negative 128 r to the 3rd s to the 1st. All we're doing is multiplying that.
Oh, I forgot that each of these equations contribute a term.
Mm-hmm.
So it'd be like 4 times negative 8.
Exactly. All these are being multiplied together. Let's keep going. What's 2 to the 4th power?
16.
Sorry, 2 to the 2nd power.
4.
4. What's negative 4 to the 2nd power?
16.
So this becomes 6 times 4r squared times 16s squared. Can someone in their calculator real quick do 6 times 4 times 16? So that'd be plus 384 r squared s squared. You see how the r exponents is decreasing, but your s exponents are increasing? We have 4 times 2r minus
Negative. This is 64.
negative 64s to the third. What is 8 times negative 64?
That's a good question. I really should calculate.
So that'd be negative 512 r s to the third, and of course the last one was negative 4r to the fourth power.
This is just 60, negative 64s.
Mm-mm.
But 60 plus 64s.
What's a negative raised to itself 4 times?
256s.
256 s to the fourth, a positive though.
Oh.
If you notice, when it's a negative on the inside, the terms alternate between positive and negative, but all the other rules stay true to themselves.
Yes.
Questions? This is actually expanding a global binomial. A lot of times they will never ask you to expand a binomial, but to find a particular term. You want to make sure that when you're looking for a particular term, you base it off of the fact that, okay, you know that r has to be to the third power, or s has to be to the fourth power, and so on and so forth, so then that way you can determine what part of the expansion you use. Do not try to expand the full binomial, because all you're going to do is waste time.
Yeah, this is time consuming as is.
Mm-hmm. Like, look at this one. It's asking you to find the sixth term of this expression. N is 12. You should not be writing out all 13 terms of this expansion. You do know, though, that you'll have 3 parentheses. What's always at the top of your first parenthesis?
12.
12. What goes in your first parenthesis?
6.
2n. What goes in your last parenthesis? And you're looking for the sixth term of this expansion. It won't be 12 choose 6, it'd be 12 choose 5. Because remember, the first term is 0. The first term is 0. So if you look at like the fourth row of Pascal's triangle, this is your 0 term, this is your first term, your second term, your third term, your fourth term.
That 0 value is probably just going to mess up a lot.
So if you're looking for your sixth term, it's always like one more.
It's
Okay?
visually,
Yeah.
but numerically.
Mm-hmm. It's gonna be one less.
Okay, fellas, let's do these.
So, what are your exponents going to be here?
5 and 7.
Is this one 5 or is this one 7?
5.
This one.
Wait, it is going to be 7. Wait,
This is a
yeah,
bottom
it
term.
needs to be 7
Because
because
it is the bottom term, and this one's
dang it.
going to be 7.
The bottom term is always the first exponent?
No, it's backwards. I'm mistaken.
that's because we're going in a decreasing order.
That's right.
So the 5th term in that decreasing order is
This is always the back end here. Look at your theorem. Look at your theorem. Your binomial theorem. You see it does n minus 1. The next one will be n minus 2, n minus 3, and then you see later on in the theorem how it's b to the r. R is always the bottom of your combination. So this back number, this back exponent is always the value of this number here. Can you guys use your calculator and tell me what is the sixth term of this expansion?
already.
Did we find the term?
Yes.
The full thing after you take 2 raised to the 7th power and multiply by whatever 12 choose 5 is? What is 12 choose 5?
792.
792?
Yep.
What's 2 to the 7th power?
128.
Becomes 128 into the 7th times m to the 5th.
It's just being its best.
Run it down. Give me the numbers, not the.
7th and to the 5th.
And that would be your 6th term. Remember, R is always at the end. The formula is N minus R, and this one is always R. Questions? Let's do this last one. Let's do this last one. I should have 3 sets of parentheses. The top of the parentheses should be A, and the bottom should be A, because I'm looking for the 4th term, which means it's technically 9 choose 3 when you look at Pascal's triangle. Second parenthesis,
A.
it should be raised to the, and the last one, again, your exponent should always add up to be N, and the last exponent is always the value of R, the bottom of your combination. What's 9 choose 3? 84 times A to the 6 times negative 8. So my final answer should be
672, 8 to the 6. These numbers are getting harder to say by the minute.
There we go. That's how you find particular terms. Okay? Actually, we do need to do this. Then this will be our last one. Okay? This will be our last one. You have expansion, x to the 2nd plus 2 over x, that's all that's being raised to the 10th power. What's the number of terms in the expansion? 11, because remember it's always one more than n. Now it's asking you to find the coefficient of x to the 8th, which basically means is that there's a term that once you expand this 11-term expansion, you'll have x to the 8th, some number x to the 8th. We want what that number is. Just the number, not the x to the 8th. So you know that you're going to need to set up your 3 parentheses.
With 10 being there.
Uh-huh.
And squared over there in the middle, and then 2 over x.
So it really is now more so of a matter of what are your exponents. Now you can sit there and you can do a trial and error, and you can be like, okay, is it 10, 0, 9, 1, 8, 2, until you figure out which one will give you x to the 8th using your laws of exponents. Okay? But that could take time. I mean, granted, 10 is a small number, but what if it's larger? Did anybody figure it out?
It's the 4th. X to the square is 4th, and then 2 over x to the 6th.
And this will
So
give
then
you
that-
6.
It's 10 choose 6.
Choose 6.
I would say.
10 choose like that.
So 4 first, then 6.
6 first.
Yes.
This will give me x to the 8th over x to the 6th. What happens when you divide exponents?
Oh no, you subtract them.
It's actually squared. So it's not 4 and 6.
6 and 4.
It should be 6 and 4.
Oh.
It should be 6 and 4.
That's in the development.
Now, if you're like, okay, well, how am I supposed to know that? You remember when I wrote this here? How that's n minus r, and that's r over there? You see in the pink?
Yes.
Okay. One way that you could do this, I'm going to do this off to the side, is that you know you're trying to get to x to the 8th. Which means that x to the n minus r times x to the r, because that's what these are, have to give you 8. Now, because this x is in the denominator of this particular exponent, technically this would be to the negative r. Does everybody understand why it would be to the negative r?
Yeah.
1 over x can be written as x to the negative 1. And because your exponents for both of these parentheses have to be n minus r and then r, that turns into a negative. What's n in this problem? N is 10. So if I replace n with 10, I have bases that are the same that are being multiplied together. What do I do to the exponents?
You add them.
So this becomes x to the 10 minus 2r equals x to the 8th. Since both of these have the same base, I can drop the bases and just say my exponents equal to each other. How do I solve for r?
Subtract 10 and divide by 2.
And what is that?
It's negative 2, so r equals 1.
I think I messed up somewhere. Oh, I did mess up somewhere.
Don't worry, so did I. And maybe some others. So I'm not speaking.
I forgot that this x is being squared.
Oh.
But it's a quick fix. If I change this to x squared, I still have n minus r there. What do I do with that 2?
Distribute.
So that turns into what?
20 minus 4.
20 minus 2r, that gets added to a negative r, so that turns into what?
20 minus 3r.
So then I'll have 20 minus 3r.
And then we just do the same thing we did, but now it's correct.
So subtract 20, what do you get?
R equals 4.
I get r equals 4, and that is what it was.
Yeah.
That's
Now this
another
is a
way.
5 points question.
It'll probably be 6, but it's still not that many points. So then we know that this would be 4. What does 10 choose for? 210. This becomes x to the 12 times, what's 2 to the 4?
16.
16 over x to the 4. We already know that this is going to give us an x to the 8. So all we're really doing is multiplying 210 by 16. What's 210 times 16? And that's our coefficient. Questions? So again, you can either get those exponents by either doing a guess or check. Be careful when you do your guess or check, it has to work out. It has to give you x to the 8th. Or you can use over here in the pink, which is basically an algebraic formula to get the value of r. But this is what we did in pattern sequences and series. Okay? This is what we did. We talked about arithmetic, geometric, sums, sequences, summation notation, and then of course, binomial expansion.
Yeah, this is the only real part.
Okay?